Hello and welcome to the Tillage Edge with me, Michael Hennessy. This is your regular update for all your tillage news and advice. In this episode, we continue in the series of podcasts looking at soils. In previous podcasts in the series, we chatted to Professor Mike McLaughlin about the basics of soils and how fertilizers interact with the soils after application. Mike came back again and again to the need for accurate identification of key parameters such as pH, P, K, and other trace elements. There are many different types of soil tests which Irish farmers can purchase, but only one method which is acceptable to the Department of Agriculture as an official soil test, which is the Morgan's P. However, whichever soil test method you use, regular testing is necessary, but also having the confidence that the test method is scientifically valid for our soils, and also knowing what to do with these results as a means of practical action on the farm, is critical for success. Today, I'm delighted to be joined by Dr. Karen Daly, a Senior Research Officer in Environmental Science working in Johnstown Castle. Karen, you've been working for some time in Johnstown. You might outline some of the main areas you've been working on over the past number of years.
So my area is in soil science, so anything to do with soil and how it interacts with the environment and how it interacts with crops. Specifically, I focused a lot on nutrients like phosphorus and on different ways of measuring phosphorus and how it interacts with water and how it interacts with plants. And then more recently into new methods for soil analysis and for capturing as much data as you can with novel methods of soil analysis.
And of course, the measuring all of those elements within a soil kind of works into, I suppose, if you like, a healthy soil or a soil that functions really well. Is there a European law, maybe I say, or directive coming out around that area at the moment?
There is indeed. There's the soil health law, which will be legislative by 2023. So the Commission has already started talking to member states, including Ireland, about what a soil health law might look like. What the Commission has in mind is something that looks like a directive, kind of like the Water Framework Directive. So it will have a framework for what a healthy soil might look like, and they would like all soils in Europe to be of healthy status by 2050. So that will involve monitoring and measuring, and for any soils that are not healthy, that will involve a programme of measures. And so we're yet to define or see what that means. What does a healthy soil look like? How is it defined by the Commission? But I would imagine, and just having been involved in some of the discussions around it, it's about getting the basics right. So we're looking at the soil quality, so your soil chemistry, your soil physics, and some of the biology, and some of that is measurable and some of it is visual. So but I think there's going to be a lot more focus on a holistic view of soils rather than looking at one specific parameter.
I actually don't envy them their job, because I know certainly on farms around me, or even here in Oak Park in Carlow, there could be 15 or 20 different soils in this farm alone, never mind all the way across Ireland or all the way across Europe, because I'm sure a healthy soil in Spain is probably looks very different to a healthy soil up here. So
yeah, absolutely. But it kind of all comes back to the focus is on functions. So what do you want the soil to do? So if we think about the soil functions, and that could be, it could be primary production, producing food, raw materials. It could be for carbon capture. It could be for water infiltration and water purification, nutrient cycling. There's a lot of different functions that soils perform. So I think the narrative around the soil health law will be around having a healthy ecosystem, so it can provide the ecosystem services or the soil functions. So again, it comes back to what are those key parameters that you that are important for you, for that soil, and for what you want it to do. So that's kind of where they're coming from there.
Okay, and talking about different types of soils, different types of environments, I suppose, look, there's a core test probably at the heart of that, and there are probably many different tests out there that can be used to test pH or P's and K levels in those soils. You might give us an idea of maybe some of the most popular ones that are used around the world in some different environments, and why they're, I suppose, for the most part, more suitable to those countries maybe than what we use here in Ireland, which is the Morgan's test.
Yeah, so like the Morgan's test is something that we've adopted here as our kind of national soil test for major nutrients like phosphorus, potassium. You can also analyze for magnesium in the Morgan's extract as well. And that suite also comes with pH and lime requirement. So they're kind of like the building blocks of getting the nutrients balanced and getting the environment right in the soil. But other countries have adopted different tests. But if you think the fundamental basis of any test is to try and see what the plant sees. So to try and simulate what's happening at the root zone. And that's what they're designed for. They're all mostly chemical tests. So there'll be a cocktail of reagents mixed together at a specific pH and used to extract out available forms of the nutrients that are in the soil. Our test goes back to a calibration trial that was first ran in 1976 in Teagasc, and we kind of calibrated the Morgan's P test to our soils, to Irish soils. And the Morgan's P test is very good and very efficient on nutrient and slightly acidic soils, and the majority of Irish soils, Irish agricultural soils, would be in that bracket. There are exceptions to that. There's often, limestone soils which can be slightly alkalinic, but by and large, the Morgan's P test, when it's compared against other tests, which we did back in the mid 90s, we reran the phosphorus trial again, and we recalibrated just to see if we could improve the calibration for Morgan's P for grassland and for crops, by including a wider variety of soils. And we still we kind of adjusted the P index system on the back of that, and we looked at Morgan's P as a test, as a standalone test, along with other tests like Malick, Bray, Olson, Colwell, calcium chloride extractable P, water soluble extractable P. But Morgan's P came out as the best predictor for Irish soil, so we've stuck with that since, and that has been. It's been a very good indicator for fertilizer requirement, and also it's used then, I suppose, as an indicator of you might be excessive. If you have excess P in the system, it's a risk indicator then in terms of water quality, trying to avoid losses of P.
Karen, can I just bring it back just a little bit? You talked there just a little bit about most of these tests or their chemical kind of process.
Yeah.
And you mentioned that they will look at the available P or available nutrients in it. Is there any of those tests that you talked about before, the Malick and the Olsons and some of those, are they all doing the same, or is there any of them that actually can measure the total volume of P, and people might get confused at that, or is there any sense of that?
So what I will say from the start is that nutrients like phosphorus or potassium or sulfur or calcium, they can exist in various forms in soil. So there'll be the total amount of that P in the soil or potassium, but it's the available fraction of that total P that we're interested in. And that's the available fraction that the plant can see. So all of the tests are chemical tests. So there'll be a mix of weak acids or a mix of alkali solutions, but they're all trying to stimulate the same thing. They're trying to just extract out that very discrete fraction of available major nutrient, whether it's phosphorus or whether it's potassium or whether it's calcium or whatever you're interested in. It's really the plant available fraction that we want to see in the test. In order to get the total amount of P in a soil sample, you would have to completely digest the soil. You'd have to break it down. So you've got organic forms of phosphorus in soil and organic forms of potassium, etc., that are, they're not easily soluble, and they're not readily plant available. So they have to be broken down first. So if you think of total P, for example, it's a function of many different fractions. So the organic fraction, the inorganic fraction, the stable fraction, and the plant available fraction. But for agronomic soil P testing, it's really that plant available fraction that we're interested in. And that's what all of those tests are designed to extract. Just extract that fraction, because that's the only fraction that we're interested in.
And of course, none of these tests are absolutely 100% accurate. And as you said, you went back and you retested the Morgans in the 90s to kind of see how close it was. In terms of accuracy, is it kind of 70% accurate, 80% accurate, or what's you kind of do a line or a chart basically to kind of figure out where it is? Where is that for your typical Irish soil? And maybe the second point of that then is that, does that change? Does it get a bit more tricky then when the pH in the soil, the natural pH in the soil, rises quite a bit?
First off, I will say, no test is going to be universal across all soil types. There is going to be a couple of wildcard soils in there that the test isn't very efficient at extracting out that available fraction of P from. So for Morgan's P, it works really well on neutral and slightly acidic soils. But if your soil is above a pH of 8, the Morgan's P test isn't all that reliable. It's pretty good on everything else, but not that reliable on very, very alkaline soils. And that's where another test like Mehlich or Olsen might come in terms of capturing a better assessment of what the available fraction is. The other thing I will say about Morgan's P is that if you have a really peaty soils, and this might not be something that tillage farmers would typically be on, but for some of the more extensive farmers under grassland, if their soil is very high in organic matter, like above 20% by loss and ignition, that's the quick test that we use for organic matter. Above 20% organic matter, Morgan's P is less reliable because you're getting a lot of interference from all that organic matter in the sample. So they're the two criteria that we try and look at, in terms of what soil type or what features we might be interested in terms of assessing whether the test is an accurate result. But by and large, the accuracy is pretty good. I can't give you a percentage because I just don't remember what it is from the trials back in the mid-90s, but it works pretty good or pretty well for the majority of soil types, apart from those two caveats.
And in terms of then, you mentioned along the line the Mehlich and Olsen test, and if I can remember rightly, the Olsen is what is used probably quite extensively in the UK.
Yeah.
And the Mehlich, I'm not really sure, but I think on the department test or the suite of the free test, I suppose, or the free test scheme they had on it, I think Mehlich was included in there as part of that.
Yeah.
Are they doing pretty much the same thing but just different names, or is there a differential between the two?
Yeah, absolutely. Like the Olsen test, that goes back to that obviously was developed and chosen in the UK. It's also adopted in Northern Ireland as well. It's an alkali solution, so it works quite well on kind of fairly basic soils. The Mehlich test has been modified at various stages over the years. So we're on the Mehlich 3 version. That's widely adopted, I'd say, in the US. Quite a lot of US states use Mehlich. The nice thing about Mehlich is that not only does it extract phosphorus in an available and plant available form, but it can also extract other elements that you can't capture in Morgan's the Morgan's test, like aluminium, iron, calcium, sulfur, manganese, copper, zinc. I could go on and on and on. A whole suite of metals, but available metals. So metals in an available form, not their total elemental composition, but their available form. And that's often really useful information because it may not be, information that we can apply to an index for aluminium or iron, but it's useful at telling us what that soil type is. So often if you have a soil that's very high in aluminium, you might expect a lot of phosphorus fixing. So you might look at the pH then and see if it's slightly acidic and bring the pH up to what it should be. And so you kind of reduce that aluminium, the effect of aluminium, which is to sort of fix phosphorus and make everything fairly insoluble. And then also if there's a lot of calcium in the soil, you might then realize that you're on a fairly high calcium soil, or you might be, and the pH might be above 8. So it gives you a lot of information about the soil itself, rather than, I suppose, you don't need 10 elements in a soil test, or we don't have 10 indices for every element, but it just provides a good overview of what that soil is like, and you can link that to the phosphorus behavior in the soil. So Mehlich is part of the department's free test scheme for that reason. It tells us a little bit more about the soil than Morgan's does, and then they're trying to sort of see if we can build a relationship between Morgan's and Mehlich to convert one from the other. And so that's kind of what we started doing here in Teagasc as well.
Okay, so that should add to the overall information. It's not just something for researchers. It's something that a farmer can use on the ground if they had that information coming back at them. But as you say, we don't necessarily have a particular indices for the various different elements in it.
No, it's not about plugging an index, plugging the aluminium or the iron or those values into an index. It's just about being able to sort of look at values that might tell you something about the soil and about it.
It'll probably still take a bit of expertise to kind of work down through it to kind of figure out what they all mean.
Yes,
exactly. Another test out there that a number of farmers have decided to look at, and again it gives a whole heap of various different elements in it, which is the Albrecht test.
Yeah,
and it has an awful lot of not just the elements in it, but the predictors of or assessment, I suppose, of the test result, which gives highs and lows and various different things. What's the thinking around that test? Can it add anything to the Morgan's test that we already have?
Well, I think the thinking perhaps might be around looking at ratios of one cation to another, or looking at the cation exchange capacity. We don't have any recommendations on the back of a test like Albrecht. It's probably useful for research purposes and understanding a little bit about your soil type and what its behavior might be in terms of how it might sort of react with how added fertilizer or phosphorus or whatever. But I'm not sure that it would add any additional value above and beyond what we can do with Morgan's, because we can extract magnesium and potassium as well as phosphorus from the Morgan's test. So you can get those elements as well in their available form, which is where we want them to be in the test, and you can make your adjustments based on that. So I'm not sure that it adds any more value to having that on top of a Morgan's test. And Morgan's will also give you, that suite that is offered will also give you lime requirement and pH. So if you can get those right, you're onto a good start before you launch into anything else.
And I suppose then the next end of it, if you have a reasonably good test, but it takes a bit of time and you're limited to the amount of, I suppose you can take them down to a per hectare or even less if you want, but for the most part, farmers are probably going to do it on a kind of 4 hectare. The holy grail, I suppose, for this, going along the line of precision agriculture and being able to apply the exact amount in the right place, would be a more rapid test, something that maybe could be brought to the field and you could build up a map in that way. What's coming down the tracks? Are there new tests that you're looking at the moment?
Yeah, so it's not so much a new test, but just a new way of testing. So the move towards green chemistry now is growing, by which I mean trying to move away from using harsh extractants, acids and alkali solutions, because that generate a lot of chemical waste, and trying to use technologies that can give you the same results. So in essence, we're using light, in particular infrared. So it's about shining a beam of infrared onto a soil sample, and with a detector we can build up a sort of it looks like a spectrograph. So it's a graph with lots of peaks, and where those peaks are positioned along the graph can tell us how much sand, silt, clay, organic matter, carbon, what the lime requirement might be. So there's a lot of parameters that you can get from this method. It's called soil spectroscopy. Spectroscopy has been around since the 1800s, but it's only in the last, I'd say, 10 to 15 years that it's been used on soils. It gives you information, but the only thing I would say is that it doesn't give you those major nutrients like phosphorus that are very dynamic in available forms. So there are some soil properties that are spectrally active. So we'll see peaks on the spectrograph that we can assign to carbon, organic matter, like I said, sand, silt and clay, some of the clay minerals, if you want to get really into, the sort of the nuts and bolts of what the building blocks of the soils are. But one thing you can't use it for will be available phosphorus. So I don't think the Morgan's P test is going to go away anytime soon. We're always going to need that. The soil spectroscopy tool is going to be able to give us a little bit more of a handle on, say, the soil functions. So it's back to the soil health thing again. having a bit more of an overview of the soil, especially now that carbon is going to be, is rather, a very important function in the soil. And if we're going to go down the road of carbon trading, then a tool like soil spectroscopy could be able to capture, percentage carbon in soil.
So when you say, Karen, there, when you say it won't be terribly useful for phosphorus in terms of the availability of it, is it the same for potash as well, or some of the other nutrients, like some magnesium or zinc or whatever? Will it tell you anything about that, or do you still have to go back to a soil test for those?
No, I think there's scope to get potassium and some of the other elements that have a spectral signature or are spectrally active in infrared, and also there's another tool called X-ray fluorescence, so XRF. They can give us an idea on elemental composition. So like if XRF is quite widely used for looking at heavy metals, but it can also look at lighter metals like aluminium and iron and calcium. And infrared can give you potash, can give you potassium, and give you, if you can calibrate it, for magnesium. So, but they're all kind of I would say they're a little bit in development. You have to calibrate it with some lab data first before you can get it working. So yeah, I mean, for the major nutrients, like those, the important ones that you need, like the available phosphorus, you still have to go back to your Morgan's P test for that. But for other things, and it can capture it in one zap rather of the soil sample, you can get multiple parameters. So you could spend a couple of weeks analyzing for particle size, organic matter, carbon, lime requirement, and a couple of other things. And but this method will remove the time and the costs involved in getting those parameters back.
And how far away do you think that these tests are going to be, or are they affordable for I don't know, can we get it into a kind of a handheld type scenario, or is it more kind of a semi-machine coming at you kind of thing?
Well, we've done the proof of concept bit at the bench. So we have I suppose the spectrometer that sits on top of the bench has done its job, and we've kind of developed calibrations for a lot of different soil properties. So we've got one for soil particle size and then texture. We can get texture from that, whether it's a clay loam or a sandy clay loam or whatever. And we've got one for organic matter and lime requirement. The next step for us now is to sort of progress that from the bench to the handheld. So we have a couple of handheld instruments that we're looking at, but it's about getting over the sample prep. So when you're in the lab, you've got a nice dry sieved sample, but when you're out in the field, it's a completely different thing. So I'd say we're probably 2 or 3 years away from getting the field level analysis ready, but we have the analysis pretty much done at the bench. Now, I wouldn't say it's rolled out on a commercial basis yet. We have it, we're kind of developing these kind of methods for people in research who might want to screen a lot of soil samples for a couple of properties instead of waiting for the labs to come back with a lot of analysis. It's handy for that. But it's not a commercial venture just yet. So I think there's probably a step to go yet before we can go from the bench to have it commercially available. But it's all in the process.
Okay, so you can obviously go nuts with something like that out in the field. If it's a handheld, you could take hundreds of different things if you want to. But anyway, we'll roll that, maybe it's in the future, but we'll roll back a little bit from that. In terms of your normal soil sampling, we'll finish up on this question, but in terms of your normal soil sampling scenario, we have, I suppose, lots of legislation, whether it's 5 or 4 or 3 hectares, all the way down then to kind of your precision sampling, which kind of does it on a per hectare kind of sample. From your point of view, what is the ideal level in terms of that intensity?
It comes back to, how you're going to manage it. So sample at the resolution that you're planning to manage the soil. So if it's nutrients, you're probably going to manage them on the 4 hectare basis. And so it'd stick with that recommended spatial sampling. If you're looking at soil health, for example, and you're worried about, say, a part of the field that might be compacted, some of the sampling and testing methods, and most of them are visual now. There's a few of them that have been rolled out. There's the visual soil assessment that you can do for tillage sites, where you can look down, you can sort of dig the spade down to 25 centimetres or 40 centimetres to try and get an idea of if there's any sort of compaction issues. So you could do them on whatever resolution or whatever spatial scale that you think might be appropriate for the field that you're in. You know, if you think the headlands might be compacted rather than the main field, you can do it that way. So there's no end to know how high a resolution you can go. But I guess it comes back to how you're prepared to manage it after that. What are you going to do with that data? You could have 100 samples from a field or one sample from a field. So are you going to manage it on 100 different management units or one management unit?
Exactly. No. Well, I suppose look at certainly for the likes of P's and K's and some of those kind of things with the variable rates fertilizer spreaders with the GPS precision. There's a possibility of doing hundreds, I suppose. But for the normal kind of guy that's out there at the moment, normal farmers out there at the moment, as you say, probably down to 4 hectares seems sufficient.
Yeah.
Karen, delighted to talk to you. A huge amount of information on that. Thanks very much for your time, and hopefully we might chat again soon.
Lovely. Thanks a million.
So that's it for this week, and my thanks to Karen for joining me on the podcast this week. Join me next week for the final episode in the soil series, where I chat to Professor Mike McLaughlin again about improving soils, including the versatility of organic manures. Finally, don't forget, if you enjoyed the podcast, and recommend it to a friend or colleague, and as always, rate, review and follow on Apple Podcast or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy. Thanks for listening, and I'll be back next week with more tillage news and advice.